All right, folks, here is a recap on today's lesson. Yesterday, we were only working with one rate. Folks, I need computers closed or tented. Meaning, today, we have, in this context, water going in, okay, and water leaking out, okay? So, you're going to have to subtract those rates from each other. For example, if water is coming in at 8 gallons per minute, but leaving at 2 gallons per minute, how much water are you gaining per minute net? 6, 8 minus 2. So that's two rates that kind of battle each other in which you have to subtract. Okay, battle I use figuratively. Okay, so what I was going to say is, in this case, or in yesterday's case, there was only one rate. It would have just only been water leaking or water coming in. Okay, now there are two going against each other. So the first part A, well, let's read here what's going on. In this context, we have it's pumped at 2 gallons per minute into the tank. It's leaking at this rate, which is a function, and there are initially 30 gallons of water. Okay? Now, part A is a review from yesterday. It's just asking about leaking out. Okay? So that means we're only going to be using this for part A. So we're going to do the integral of that. We're going to do the integral of this 0 to 8 because of these. Does that make sense? Okay, it's literally what we did yesterday. Take the antiderivative of this and it becomes that. Plug it in and you get 52 over 3 that is leaking out. Does that make sense, folks? Okay. Now, let's see if I can do this. Okay. I'm going to take this. Whoops. Erase. Two rates. Come on. Right here. Boom. And let's get this 52 over 3. Copy and paste it. Come on, computer. Come on. Let's do a snapshot. There. Okay, that'll work. Whatever. So 52 over 3. Boom. Okay. I just want to get that queued up. So, here is boom, boom, boom. How many gallons of water are in the tank at T equals to 8? Okay, so this is actually really easy. We have our initial amount. Okay, let me throw in some colors over here. We have our initial amount, 30 gallons. Are you guys with me? We have how much left, okay? How much leaks out of the tank. That's literally what we just did. Are we good? Ignore this 2 minus. You guys with me? That's how much left. Now, the 2 is how much was gained from 0 to 8. Does that make sense? So gain minus leak, okay, gives you net. Does that make sense? Okay. And so so now you can separate this out because it's a minus sign and we have addition subtraction property of integrals. You can separate this integral and put an 8 and put a 0. And we actually already calculated this from the previous slide, 52 over 3. If you look here, okay, 52 over 3, peekaboo, I see you, okay? All right, so now you know where the 52 over 3 came from, right? All right. All right, now, so this 52 over 3 is right over here. Let's go pink from the previous slide, part A. Now let's talk about this 2 real quick. It's easy. The integral of 2, can we agree is 2t? Okay, and then you just do 2 times 8 minus 2 times 0 gives you 16. Now, that's the calculus. This green highlights is the calculus official way. But let's use common freaking sense, dude. Okay? Common sense says if you gain 2 gallons per minute and 8 minutes pass by, well, by golly gee, how many gallons do you have after 8 minutes? 16. So crazy, huh? Okay. Does our common sense way match the calculus way? Yeah. Okay. So again, back to, let's zoom out. Initial and gain minus loss, aka 2 rates. This is the rate of gain, rate of loss. Integral that, and you return the rates back to the amount level from 0 to 8 because it's 8 minutes. I said a lot of words for a very easy concept. Are you guys understanding what I'm saying? Okay. Last part of this example. Okay. Let's look over here. What is the, okay, let's blow this up. What is the maximum amount of water 0 to 8? First of all, this was from your original, well, let's recap like this. Do you guys agree, this is literally from yesterday, do you guys agree that, okay, do you guys agree that the humps, aka minimum maximums of F regular are the x-intercepts of F prime? Are you guys with me on that? We did that yesterday, okay? So this right here, okay, this was from the prompt, from the question. Are those rates or are those amounts? Which level are they at? Those are rates. Okay, this was the rate of gain. This was the rate of loss. Rates is F or F prime? F prime. So this is the graph right here of F prime. Does that make sense? Okay, that's a graph of F prime. So we're looking at the x-intercepts. Okay, and this is, so at x equals to 3, okay, you look at the x-intercepts, basically second trace on your calculator. At x equals to 3 is your hump on F regular. And remember, if F prime is your rates, what's F regular? Your, what? It starts with an A. Amount, okay? F regular is your amount, okay? So let's do a really rudimentary graph. This part is not really necessary, but let's just do it. Do you agree in this zone, slopes, aka F prime, is positive? So F regular is going to look something like this. Okay, that's slope positive for F regular. Do you agree in this zone, F prime, aka slope, is negative? Meaning slopes are negative for F regular. So this looks like a local min or max? Max. Now, by the way, folks, if your graph looked like this, these are slopes going from negative to positive. So F regular would look like that. You see what I'm doing? Okay, all right. Now we just use this thing right here, okay? All right, the candidates test. Plug in the endpoints, plug in the humps, see what your min-max is. Okay, in this case, it's asking for the max, I believe. Yes, it's asking for the max. Folks, this red, is that the rates or amount at this with this red? It's the amount because you see an integral. If you see an integral of the rates, it returns you back to the level of amount. And remember, they're plussing, and a key feature, a key clue is that they're plussing that 30, okay, which is your initial amount. So this is your amount. So we plug in the endpoints. Remember, 0 to 8 is your interval here. You plug in the endpoints into this on your calculator. Okay, remember, you go to math option 9 usually, and then and plug in 0 and 8 for t separately. Okay, do this once with 0, do that one with 8, and you get these two numbers, 30 and 28.1, 28 and a third. And then why do we plug in this 3 right here? Why this 3? That was the x-intercept exactly right here. Okay, you plug that 3 and you get this. So what's your what's your max here out of these three numbers? 31 1/3. Are we good? Okay. Now so that's really the only example I need to go over. This one is just kind of a repeat, but it's good to just gloss over. I'm not going to go over in detail because this is an AP FRQ, an actual AP FRQ. Okay. So right off the bat, this should take me less than 5 minutes. Okay. Rate. Are we good? Okay. This is the rate of unprocessed gravel. Okay, so imagine you have a factory that receives unprocessed gravel, okay, like from nature or wherever, raw unprocessed gravel, and then in the factory they process it so that they can use it in construction. That's the idea, okay? And this is your initial amount, that's your interval, and this is your process, how much gravel they process per hour. Okay, all right. So remember, we're doing two rates. Usually one's a gain, one's a loss. One's coming in, one's coming out, and the two rates are battling each other. So do you agree this is battling that, so to speak? Okay, because this is unprocessed versus process. Okay, so when you do these FRQ questions, hopefully at some point, you're going to start categorizing what kind of FRQs they are. Meaning you just eyeball an FRQ and you're like, oh, this FRQ has to do with limits. Oh, this FRQ has to do with U sub. Oh, this FRQ is blah, blah, blah. That way, you can just once you start identifying what kind of FRQ is, you can just look at key features rather than having to read every single word and then figure out what the question's asking. You're going to see you're going to see the patterns of each type of FRQ and be able to eyeball and categorize the FRQ when you see it. Does that make sense? Okay. So hopefully at some point you don't have to really zoom in and read every single little detail. Like for example, does this problem really have to do with gravel? No, we could be talking about balloons or unicorns, okay? Unicorns coming to Earth to visit you and unicorns leaving Earth back to whatever planet they're from, okay? All right, so it doesn't matter, okay? So that's why I'm saying, once you know the pattern in these FRQs, Alfonso, you don't need to know the details. Okay, it's kind of unnecessary. So I highlighted the stuff that you need for this problem. Anyways, I digress. Okay, you know me. I start talking about unicorns, but I just start going off on tangents. Okay. Anyways, now this is a rate. Do we agree? So you can think of this as V of t. Are we good? Now, if we're taking the derivative of a rate or a derivative of v of t, what do we get to? A of t, or acceleration, or how about this? The rate of rates. Okay, the rate of rates. Okay. Let's frame it in acceleration and velocity context. If acceleration is positive, velocity is increasing or decreasing? Increasing. Let me say that one more time. If acceleration is positive, velocity is increasing. The graph of velocity has a positive slope. Okay? If acceleration is negative, okay, that means velocity is decreasing. Okay? Because remember, acceleration is the derivative, aka slope of velocity. Does that make sense? Acceleration is the slope of velocity. So if acceleration is positive, that means the slope of velocity is positive, which means, remember, this is the graph of v of t, hypothetically. Okay, so if acceleration is positive, the slope of velocity is positive, meaning velocity is increasing. And if acceleration is negative, that means the slope of velocity is decreasing, aka the slope of velocity is negative, which means velocity is decreasing. Does that make sense, folks? Okay, cool. Now, anyways, so we have g prime of 5. So I'm going to plug in, okay, if g prime of 5, I'm going to plug in 5 into g prime just using your calculator. Okay, I should have said it's a calculator problem. And you get this. So in the context of acceleration velocity, is that positive or negative acceleration? Negative acceleration, which means velocity slopes are negative, which means velocity is decreasing, hence decreasing by 24. Does that make sense, folks? Okay, I said hella words for something that should be pretty simple. Okay, now find the total amount that arrives at the plant. Amount. If they give you a rate, right off the bat, you think amount, what do you think of? Starts with an I. Integral. So right off the bat, integral 0 to 8 of the rate function, which is g of t right here. All right, and you get this. Now, how come you don't add the initial amount? How come we don't care about the 100? In this case. Because it's the net change. It's how much arrived. It's not how much total. If it asks for total, then you got to add 100. We good? All right. C is the amount of unprocessed gravel increasing or decreasing at 5 hours. Let's see. Okay. So I'm going to plug in 5 hours into here. 5 goes in there. Okay. All right. And I get a positive number. I get 98.140. Okay. So this is I don't really agree with this wording. I don't like this wording. Okay, I know what they're trying to say. Okay, I'm not a fan of this wording. Okay, so we plug it in and we get 98, right? But give me 1 second. Let me see if I could word this better. Yeah, maybe I'll think of a cleaner way and make it in the notes make it in the in the comment or something like that in the YouTube video. But anyways, this is what it's trying to say. When you plug in 5 into t, you end up getting 98, and that's the velocity basically, right? That's the velocity. But that's the velocity of unprocessed. What's the velocity of processed? 100. Which velocity is less than 98? So the unprocessed, remember this is unprocessed and that's processed. The rate of unprocessed is less than processed. So that means the unprocessed is losing, aka decreasing at that time. Does that make sense? Okay, they should have worded that one better. Okay. Anyways, this is the same as the first example that we did, the last part. Okay, you got your initial amount, you got your, you got 2 rates battling each other, and then we plug in the endpoints and we plug in the x-intercept and just do which one's the maximum. Okay, that's all I was doing. All right, folks, that's it for today's lesson.